I'm recording this now. And here is the very start of a truth table. So if you've never done this before, follow along, and you'll see it's not that big of a deal. So when you have Boolean conditions or Boolean variables, you can make a truth table. And what you usually do is you start off with something like this. We have condition A and condition B. And these are all the ways you can combine condition A and condition B. So for A, I always do, you have four places. You do true, true, false, false. And then for B, you just alternate true, false, true, false. And these are all the ways you can combine two things that can have two states. I mean, it could even be two coins, heads, tails, heads, tails. You could have heads, heads, you have heads, tails. You could have tails, tails, and tails, heads. There's different arrangements. Anything that can come up in two different ways, you can arrange like this. Okay. The first column is all the values for A, true or false. And the second column is all the values of B. Sometimes people like to do these truth tables with ones and zeros, like in computer science, instead of T and F, and that's fine, whatever works for you. So I just show you a couple examples. This first row shows you where A and B are both true. And the second row is where A is true and B is false. I'm not going to go down the whole thing, but that's how you read this. Okay, so for me anyway, in this class, you would always start your truth table like this. With the A being true, true, false, false, and then B being true, false, true, false. Now things get more interesting when we add another column. So I'm adding another column, and at the top I'm writing A and B, and I'm using the Java notation for the and. And our job now is to fill out that column using the columns for A and B. And the rule is very simple. When you're doing an and, both the conditions leading up to the and, both have to be true, or you put false in the column. So if we look at this first row, A and B are both true, so we would put a true here. All the other ones, we would put a false in there because they have to both be true. And I know when I first learned this years ago, I was confused. I thought, well, what if they were both false? Aren't they the same? Isn't that also a true? But no, they have to both be true, not the same. They have to be true. So what we get for this is the top row of this new column is a T for true, and all the other rows are false because you need both A and B to be true in order to have an A and B column be true. Any questions so far? Okay, so we're going to add another column, an A or B column. And the way this works is if either A or B is true, then this column will be true. So this will be more generous with its true statements. A and B, here this first row, definitely have a true. See the second row, there's at least one T here. We'd put a T at the end. Third row, there's at least one true, so we'd have a true. Fourth row, finally we have a false. There's nothing true about A and B both being false, so we'd put a false there. So it looks like this, true, 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 false. And so the or is, the and, they both have to be true. The or, either one has to be true. All right, so we're going to do another one. And I want you to look up at the top. I've got this sort of crazy Boolean expression, not A and A or B. All right, and so I'm showing you in just a sec how we can use a truth table to work this out. What I would first do is fill out the first two columns. So I think, I've got my totally mindless. You don't have to think, oh, how do I do the first column? You got to go true, true, false, false for A, and then go true, false for B. So that just lays out all the possibilities for A and B. And then what I do on these is I break up the whole rest of the logic. We have a not A. That's something we got to work out. So here's not A. And then we have an A or B. And I'm going to make a column for that. And then this final column is the expression we're trying to evaluate. So I'm hoping in my notes that I do the not A column first. And that would just be the opposite of whatever was in column A. So we'd have a false, and a true, and a true. Good. I did what I hoped I would have done. See, not A is false, false, true, true. Okay, and then next, we're going to work out this A or B column. I mean, we just did that in a previous screen, but that means if there's a true in either A or B, we're going to put a true over here. So this will end up being true, 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 false. Good. All right. And then for the last column, we don't have to do it all, like that's a lot to hold in your head at once. All we have to do is look at these two columns and know that we're doing an and. That's why we did these two columns. So we didn't have to like think 3 levels deep. So this is an and so anywhere where these, the third and fourth column are both true, we're going to put a true in the far column. And anywhere where they aren't both true, we're going to put a false. So we would be false, false, true, false. And I drew these crazy arrows because Google didn't let me just draw with a pencil, but I was trying to show you we're using the third and the fourth column to get this fifth column. You don't have to worry about like everything else. That's why we did the not A column and the A or B column, is because then it'd be easier to look at just these two columns with an and do the last column. So that's an example of a truth table. So I got a little place I want you to practice it. Anyone have a question before we practice it? Awesome. I got to post the truth table thing. So hang on. All right, here it comes. I just made a Google sheet with 2 truth tables in it, and I just want you to fill it out, and I'll show you on my screen as well. Okay, so you want to go to the Google Classroom, and I'm not seeing it. Hopefully it'll show up when I refresh. Good. Yeah, it just didn't refresh. And then what I don't know, I think if I edit this one, it's gonna do it for all of you. So I better make a copy. And then I put a little thing in here that checks your last column. For you, kind of to tell you if you got the right answer. But so right now it says incorrect. But so let's give it a try. Do capital T's and F's because that's what my little checker is looking for. So if you're feeling a little timid and you're not sure what to do, I'll get you started on the number 1 problem. We're going to fill out this column first, this not B column. And that's literally just the opposite of what's already in the B column. So I'm going to hit caps lock on my computer and I'm going to do F and then T and then F and then T. So that's what that not B column means. And then the 4th column for problem 1 is comparing the A column and the not B column and doing them together as an OR. So again, I'm going to let you do that now. So if it helps, I'm showing by highlighting the two columns that are making up the fourth column. And because we're doing or, if either one is true, you put a true. And if you got what I was expecting, then over on the right where it says answer check, it'll say correct. So then go ahead and do number 2. And for all these, you can do it just step by step. You don't have to look at the crazy last part of the answer and get freaked out. Like you can do not A. That's the opposite of the A column. That's easy. And then you can do A and B. We've done that already today. And then you can do not A and B. So that turns out to be an expression that's always false. Probably not a great thing to do in a computer program. Like why bother if it's always going to be false? Anyway, it is what it is. Famous last words. Any questions about this little spreadsheet? I'd love you to put your name at the top just to make it easy for me to review it. Except in that spot. Thank you. All right, we're going to move on. So we're back to notes. And if this happened too fast for you or you got left behind, that whole section, even the spreadsheet, that's in the video too, that I'll post after class. So the second part of our notes for today is almost the end of our notes for the whole unit. It's 3.6, De Morgan's Law. And De Morgan's some, 17th, 18th century mathematician. And he came up with a rule that we can use to simplify complicated Boolean expressions. It's a little bit like the distributive property from regular algebra, but it's for Boolean expressions. And so let's take a look. It has two basic forms. If you have a not symbol in front of an and, a Boolean compound and expression, you can turn it into the expression on the right. And a way to think of it is you can not the first part. You can, if you not an and, it becomes an or, and then you not the second part. So it is really like the distributive property. The not goes to the first part, the middle part, the operator, and the second part. And likewise, if you started with an or, you do the opposite of A, and then you do an and the opposite of B. I think it's best just to think of it like distributive property. So here's two examples. we have num modulo 2 equal 1 and num modulo 3 equals 0. So, but there's a not out in front. So what it becomes is num modulo 2 not equal 1 or num modulo 3 not equal 0. I know it seems kind of crazy, but it is what it is. It works this way. And this one, we have not a equals 7 or b equals 9. And that becomes a does not equal 7 and b is not equal to 9. Again, you're just applying the distributive property to each, not distributive property, De Morgan's rule, but like the distributive property to each part of the expression. Oh, funny. Here we go. Yeah, I worked them all out. So some more info. If you're doing an equal comparison, it changes to a not equal. And if you have a not equal comparison, it becomes, equal. And then we've got the 4 greater than, less than possibilities. And the simple rule is it flips the sign. So a greater than becomes a less than, but you have to remember to add or remove the or equal to part. But if you think about it this way, if the expression starts like age greater than 57, what's the opposite of that? Well, that would be equal to 57 and less than 57. It's if you're not going to be greater than something, then you're going to be less than or equal to something. So I didn't put this all up so you'd write it all down feverishly and memorize it, but each of the greater than, less than things becomes its opposite. And then if you look at the bottom of this slide, it's an important, there's an important thing. I've got an example, and these are variables, not Boolean variables. These are like integer variables, let's say. And if we say, sometimes people, on the bottom right here, I say note, it's not a less than or equal to b. When you're applying De Morgan's law, the not symbol to variables that hold numbers, you don't put a not symbol in front of like an integer variable. You have to flip the sign. So for this one, if we want to do a not on a greater than b, we end up with a less than or equal to b. And then we change this and to an or. And then for this c not equal to 12, the opposite of that would be c equal 12. You don't do like not c, not equal. Anyway, you don't put a not symbol on a variable that contains a number. You'll see. If, however, you are using Boolean variables, then you do just put the not in front of the variable. So here's an example. I've got a Boolean variable called is hot and a Boolean variable is windy. And if we were going to apply a not to this expression, you would have a not in front of the is hot when you were done. And then I think this might be the last point, but we'll see. You can, of course, use a not with any single Boolean expression. So look at this down here. If not name1 dot equals name2, that's basically saying if name1 is not equal to name2. Another way to do that would be to say if name1 dot equals name2 equal false, but this is easier to just put the not in front. And the reason that works is because dot equals is always going to return a true or false. Okay, yeah, we have one more example. And I say these things can get a little bit crazy. So you can just do it one step at a time. So I have this pretty gnarly expression up at the top, and rather than try to do the whole thing at once, I just put the not onto the first thing. If we're going to do the opposite of a greater than b, that would be a less than or equal to b. and then I changed the and to an or. But then instead of trying to do the whole rest of it, I put this not in front of there, so I could just do like one step, and then I, as a second pass, I applied that not to this inner level, and did each thing appropriately. So when it gets a little scary, you can always dial it back and do it in steps. Questions? Okay. I have a Google form that I don't remember what it looks like, but it has 10 questions and it does things on truth tables and De Morgan's law. And it's one of those ones you could run over and over again. Like if you don't do well, then you should, read my instructions for what went wrong, and then try again. At the very least, you could try again, a little later. Let's see. So not this one. And the slide deck's there, and today's video will be here as well. So after class. So De Morgan's law. Yeah, you know what? There's no truth tables in this thing. It's just De Morgan's law and then some substring practice. So the title of it is misleading. This will be great. You'll get some immediate feedback. And work on that now. And then I am gonna assign a few more coding bat problems. So let me line that up. And that'll be what we do today.
Oh, and half of it's chapter 2 review.
I'm gonna pound on substrings until everyone gets an A. So forever. I'm just kidding. Yeah, you can turn your cameras off while you're working on things. Somebody asked. And I just posted, I have 4 coding bat problems I want you to do today. And let's just say there's a possible scenario. What if you did this Google form and you got, say, less than 5 of them correct? Great. Hopefully you'll take a minute and read my descriptions. But then maybe do some coding bat problems. And then come back before you leave class today. Go back to the Google form and try it again and try to get a better score. You know, like with a little break in between. I think it could be great. The Google form, powerful thing about that Google form is you literally can you can do it as many times as you want, and it's great practice, you know, unless you're just memorizing what to put there and you don't understand it. But let's assume that you're not just memorizing it. It's great practice, and it doesn't use resources, you know. It's just bytes in a database somewhere. So it's not like you're wasting paper. I'm a convert on this now. Because I found over the years, a lot of people, when I hand out a worksheet and we do a worksheet in class and then I put up the answers, a lot of people don't check the answers. They just think, oh, I know I got it right. I don't need to pay attention when he's going over the answers. But the Google form, you know, I mean, unless I put it together wrong, it gives you immediate feedback. And then you're like, oh, snap, I only got 4 of those right, you know. Then you could try it again and get 10 of them right. You know, that's pretty cool. I think